Terms in probability. Random experiment. Toss a coin. Can you predict what will appear on the topmost face, head or tail? No, we can't say whether it is head or tail. This means there are two possible results, namely head or tail. Now, throw a die. Can you predict the number that appears at the top surface? No, it's not possible. Any number that is 1, 2, 3, 4, 5 or 6 can appear at the top surface. This means there are 6 possible results. Such types of experiments are called random experiments. An experiment is said to be a random experiment if its result can't be predicted with certainty. This means the experiment has 2 or more possible results. Outcome. The result of a random experiment is called an outcome. We have just seen that when you toss a coin, there are 2 possible outcomes, head or tail. We also observed that if a die is thrown, there are 6 possible outcomes, that is 1, 2, 3, 4, 5 or 6. Equally likely outcomes. When we toss a coin several times, we will not get head as an outcome every time or tail as an outcome every time. Head or tail are equally likely to occur. If we roll a die, any number from 1, 2, 3, 4, 5 or 6 may appear on the topmost face of the die with equal chance. This means each number is equally likely to occur. Thus, a given number of outcomes are said to be equally likely if none of them is expected to occur in preference to the others. Sample space. The set of all possible outcomes of a random experiment is called the sample space. It is denoted by S or omega. For example, when a coin is tossed, the possible outcomes are head or tail. Therefore, head and tail are elements of set S. Each element of the set S is called a sample point. Here, the sample points are head and tail. The number of elements in the set S is denoted by n of S. Here, n of S is 2. In the other example of throwing a die, the number that appeared at the top is any one of 1, 2, 3, 4, 5 and 6. Therefore, these numbers are elements of set S. Therefore, n of S is 6. The sample space is called finite sample space if n of S is finite. Let us now toss 2 coins simultaneously. Tossing a coin 2 times is the same as tossing 2 coins simultaneously. Can you guess what is the sample space S here? Here S contains elements HH, HT, TH and TT. Therefore, n of S is 4. Let us now toss 3 coins simultaneously. Here too, tossing a coin 3 times is the same as tossing 3 coins simultaneously. What is the sample space S here? Here, S contains elements HHH, HHT, HTH, HTT, THH, THT, TTH TTT. Therefore, n of s is 8. In the same way, rolling a die 2 times is the same as rolling 2 dice simultaneously. The sample space is as shown here. Therefore, n of s is 36. Favorable outcomes. The outcomes satisfying the particular condition are known as favorable outcomes, and a set of favorable outcomes is called an event. Consider the example of a die being thrown. We know the sample space is the set of sample points 1, 2, 3, 4, 5 and 6. Out of these sample points, if we wish the favorable outcomes as even numbers, then the set of favorable outcomes is the set of sample points 2, 4 and 6. This set of favorable outcomes containing elements 2, 4 and 6 is known as an event. An event is always a subset of sample space. Events are always denoted by capital letters A, B, C, D, etc. other than S. In the example considered earlier, if we denote the event of getting even numbers as A, then set A contains the sample points 2, 4 and 6. Thus, the number of elements in event A is 3. We can write it as shown here. If we consider event B as the multiples of 3, then set B contains the sample points 3 and 6. Therefore, number of elements in set B is 2. We will now solve a few examples based on what we have learnt so far. We have to find the sample space S, number of sample points n of s, events P, Q, R using set, and n of P, n of Q, and n of R for the given examples. In the first example, 3 coins are tossed simultaneously. When 3 coins are tossed simultaneously, sample space S contains elements as shown here. Therefore, n of s is 8. P is the event of getting at least 2 heads. At least 2 heads means 2 heads or more, but not less than 2. From the sample space, we shall select the sample points which have 2 or more heads. Therefore, set P contains elements H, 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 T, H, T, H, and T, H, H. Therefore, n of P is 4. Q is the event of getting no head. This means event Q has only tail. We select the sample point which has only tail from S. Therefore, set Q contains elements T, T, T. Therefore, n of Q is 1. R is the event of getting head in second coin. This means from the sample space, we have to select the sample points which have H in the middle. The first and third coin can be H or T. Therefore, set R contains elements H, 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 T, T, H, H, and T, H, T. Therefore, n of R is 4. Let us solve one more example. Here the random experiment is to form 2-digit numbers using the digits 0, 1, 2, 3, 4, 5 without repeating the digits. As we have to form 2-digit numbers, By using the given digits, 0 cannot be at the tens place. Each of the remaining digits 1, 2, 3, 4 and 5 will form 5 two-digit numbers. Therefore, the sample space set S contains elements as shown here. Therefore, n of S is 25. P is the event that the number is even. We shall select the even numbers from the sample space. Therefore, set P contains elements 10, 12, 14, 20, 24, 30, 32, 34, 40, 42, 50, 52 and 54. Therefore, n of P is 13. Q is the event that the number is divisible by 3. The numbers divisible by 3 from the sample space are 12, 15, 21, 24, 30, 42, 45, 51 and 54. We write set Q as shown here. Therefore, n of Q is 9. R is the event that the number is greater than 50. The numbers greater than 50 from the sample space are 51, 52, 53 and 54. Therefore, these numbers are elements of set R. Therefore, n of R is 4.